This video will go through the process of unsupervised classification in Arc. Um, I just found in putting together this lab, there's just a lot of unfamiliar workflows, so a video might be helpful. So this is the Central Valley scene that we've seen before in another demo in class, and my goal is to classify this into three classes. So a really simple toy example here where we'll classify into vegetation, bare ground, and water. Yeah, that's right, water. So anyways, I'm starting with my uh, 6-band Landsat image here, and then I've also previously made, which will be true for you as well in the lab, a validation data set. So these are, I've got only 30 points here, which is not nearly enough. In your data set, you'll have 140, which you'll use to evaluate the classification. So I'll come back to that a little later. First thing I want to do is go through the actual unsupervised classification process. So first of all, for this whole process, it is important to know that you need to know the numeric classes of your class names because pixel values are in numeric form rather than in word form. And so for the lab, I lay that out for you that like water should be 1, dense urban should be 2, etc. In this example, we've got water being 1 for ground for clustering. I have to have a different number for supervised classification, but you can ignore that for now. So the classes are 1 for water, 2 for bare, and 3 for vegetation. So clear that, get out of there. So, okay, let's go into our geoprocessing here. ISO cluster unsupervised classification. So ArcGIS does not have a k-means classifier exactly because it's simply not as good for multispectral data as this ISO cluster process. It's fundamentally very similar in that you're searching for distance from class mean centroids, but it does a little better in terms of dealing with the statistical differences among the bands in an image. So we are going to view it as fundamentally similar to k-means, and just move on. So I've got my input raster bands here. Now, one of the things I'll have you do is run this process for a single band and compare it to all bands. But for now, I'm just going to grab all bands at once. Now, number of classes, this probably would be better to say number of clusters. So, because that's really what we're producing first. So this is not going to be the final map. This is going to be the way that the algorithm decides it is reasonable to divide up pixels into different clusters based on their spectral differences. So a normal protocol here would be to take the number of ultimate classes you want. We have 3, and at least double that for starters. And then we'll go through a process of merging and reassignment to get to our final map. So I'm going to put in 6 here, 3 times 2. My output classified raster, I'm always going to put everything in my project default folder. Definitely important, and name everything intuitively because there's going to be a lot of outputs. So this is going to be our all band ISO, we'll say. And I usually put a .tiff at the end there just so it knows what kind of image it is. Not going to worry about these. Don't worry about it. Don't worry about that last one. So all throughout the lab, if I don't tell you what to do with a given field, you probably don't need to do anything with it unless it's something you're already very familiar with. So we will run this guy. And here we go. We have some kind of output. We have 6 classes. You can see there's obvious differences and crisp borders, which is a good thing. I mean, it is cohering with some kind of land cover boundaries. So we need to now go through the rather manual process of reclassifying these clusters. So I'm now going to use the reclassify tool, just in case you haven't already figured it out. The tools, if they're in different toolboxes, it does not matter, they are the same tool. So reclassify, and oh yeah, parameters. Okay, hit the wrong button. So we've got our input raster, which is now going to be the ISO output, and we're reclassing on the value field. That's the only field we have in a raster, single band raster image. And now we have 6 values, and we get to assign new values. So the new values are just going to be 1, 2, and 3. 1 for water, 2 for bear, and 3 for vegetation. So if we look at 1, 1 is gray. That is obviously water. So we're going to leave 1 as 1. 2 is orange. We're going to have to see what is orange. To me, that looks dark, and that's going to indicate vegetation, I think. But you know what? I'm going to reload this image in a false color to get a better handle and make sure I'm right on that. So I just loaded this image as a 743 image because I wanted to get moisture from SWIR 2, near infrared for veg robustness, and red for chlorophyll, so we have a better idea of what's going on. So we were looking over here in the orange, and you can see I was wrong. So it was good that I used this other band combination. I can see this is actually a fairly mixed area compared to the super bright green ones, which are going to be low in band 7 and high in band 4. So this presents us with our first kind of confusing, like, is this bear, is this veg? I'm still going to say this is veg. There's other orange areas that, like over here, that are pretty veggy. So I'm okay with that. So let me go back to where are we? My geoprocessing tool. And what was that? That was 2. We're going to have that be veg. So veg was 3. We'll go to the bright green. Bright green definitely looks bare. So 3 is going to be 2. 4 is a cyan. Cyan is definitely bright green, so 4 is going to go to 3. I'll finish this up and pause it for a sec. Okay, so this process can take a little bit of time because you have to make some decisions here. So I assigned 5, which was purple, to veg, even though it's borderline. You can see up here, definitely more veg than this red over here. And then red, which was 6, I assigned to bear. So hopefully that lines up with my thinking when I made this validation data set. So, all right, we got our reclass, and I'm going to make sure again to properly rename that. I will go the all band ISO, but then I'll put in an underscore RC to say that it's reclassed. All right, run that. And now we have our good looking map, and I need to symbolize this so it's intuitive. So 1 was water, 2 was bear, and 3 was vegetation. Okay, so we've got our map, and the nice thing is once I do this symbolization once, all other products that come out with this 1, 2, 3 coding, you can just transfer the symbolization over to it. That's in the instructions. So that's it for unsupervised classification, and I'll make a different video on accuracy assessment and supervised classification.